Threadripper. It's the platform that everybody loves to be excited about, and this is the MSI Gaming Pro Carbon AC. But don't let gaming fool you in the title. This motherboard is all business. If you've been living under a rock, Threadripper is the new performance king on the block and the high-end desktop platform. If you're looking to build a monster machine with a ton of cores and a ton of performance, well, your only real choices are Intel i9 or, Ryzen Threadripper, or possibly, even an Intel Xeon. Threadripper sits somewhere between the i9 and the Xeon platform. Xeon is all about validation and performance and error correcting memory and those kinds of things. And really, you get that with Ryzen Threadripper. The server equivalent of AMD, of course, is AMD EPYC, but we're really going to talk about Ryzen Threadripper, and it's positioned as a workstation class, or sort of a quasi workstation class, as you might imagine, with gaming being in the title of the motherboard. These are quad channel, 60 PCI Express lane CPUs from AMD, and they pack quite a punch. Now I'm going to be testing the Threadripper 1920X. It's got a base clock of 3.5 gigahertz, an XFR boost clock of 4.2 gigahertz. This thing is serious. It means business. So this Threadripper platform with its quad channel memory is a monster. It will support quad channel memory up to 3600. That is an overclock. The maximum non-overclock speed is 2400, but 2666, 2800, 2933, those should pretty much be within the realm of possibility for everybody. Now, so of course, ECC testing, I've got to always do that. I don't have a quad channel ECC kit. Anybody out there want to send me one? But I do have dual channel, and so I tried one stick on each node, as well as two sticks on one node. And Linux reports ECC is working correctly. I was able to confirm this by overclocking the memory and introducing some errors, and sure enough, I get the kernel messages that errors are being detected and corrected. So good job, MSI, we got ECC. Starting at the top edge of the board, we've got our dual 8-pin power connectors for CPU power. I mean, that's a ridiculous amount of CPU power. Well, it's extra 12 volt for the whole board. Then we've got our two 4-pin fan headers, as well as our boot diagnostic LEDs right next to those. These are 4-pin PWM DC fan headers, so you can use them for whatever. I'd recommend your CPU or water pump, high current type devices. Then we've got our 24-pin ATX power connector and our first two SATA 6 gigabit per second SATA ports. Then we've got 6 more 6 gigabit per second SATA ports. Then we've got our 2 more right angle USB 3.1 Gen 1 front panel connectors. That's 5 gigabit per second USB 3.1 ports. At the bottom edge of the motherboard, we've got a lot going on. There is a J-Slow connector, which is used for extreme liquid nitrogen overclocking if you want to do that on this board. We've also got our front panel USB 3.1 Gen 2 10 gigabit per second Type-C port, power and reset, a digital post LED code readout thing, and then we've got the MSI overclock switch. This is the thing that you can turn up to 11, just like in Spinal Tap. And this is some preset overclocks that work really well with the Ryzen CPU. Little bit much on the voltage, but hey, lowest common denominator. I'd recommend you tune and find your own overclock, but hey, if you want to use the knob's there, and it works just like you'd expect. You basically it's like, okay, let's try one, let's try two. Maybe a binary search is a little bit more your speed. And then we've got two USB 2.0 headers for internal peripherals or whatever you might run. Next to the USB ports, we've got our front panel connector, our TPM header, a power input for demonstrating LEDs. If you want to do that, there's a button on there for that. We've also got 3 more 4-pin fan headers, DC or PWM. Then we've got our RGB headers. We've got the digital RGB header, but we also have the analog RGB header as well. And then we've got our isolated front panel audio connector. There is so much stuff on this motherboard that the CMOS battery is connected through an external header, and so here's your other battery header that's right next to that for resetting and doing whatever. Then we've got another 4-pin fan header, and right next to that you've got a 6-pin power input. Yes, this is a PCI Express auxiliary input. Think about it. If you're going to be running 4 high-end graphics cards in this system, each graphics card can pull up to 75 watts from each PCI Express slot. There's just not enough voltage on the motherboard to do that. It's going to have to get auxiliary power from somewhere. Now, one of the more exciting things about Threadripper is all those PCI Express lanes. If you are a crazy person and you really are going to run a ton of M.2 drives simultaneously or in RAID or whatever, all of these M.2 slots are wired directly into the CPU. On the Intel platform, they're wired through the PCH, meaning that all the M.2 slots, typically, at least on the motherboard implementations that I've seen on Team Blue, they all share bandwidth. So the maximum combined throughput of all your M.2 on Team Blue is only about 4 gigabytes per second. Here on this motherboard, you can be moving it up to 12 gigabytes per second with 3 4 gigabyte per second M.2s. And the new Samsung Evos, the 960s, those move at about 3.5 gigabytes per second. Toshiba's got some really high performance NVMe as well. You know, it's pushing 2.5, 3 gigabytes per second, no problem. So if you want really high-end performance, you're gonna need the PCI Express lanes. You can also run other high-speed peripherals. Video cards, of course, are the obvious ones, but also high-performance network cards and things like that. That's one thing that I would have liked to have seen on this motherboard, a nice 10 gigabit per second Aquantia NIC, but hey, I've got all these PCI Express slots, I can just add it. It's not a big deal. The M.2 configuration, of course, is two 80mm M.2s, and then we've got one massive M.2 that's 110mm. So if you want to go for the extra long footprint, you know, we might see 4 terabyte M.2s in the 110mm format before too long. That would be pretty crazy. At the back of the motherboard, we've got a combo PS2 mouse keyboard port. We've got 2 USB 2.0 ports. We've got 8 USB 3.0 Gen 1 ports. Then we've got 2 USB 3.1 Gen 2 ports. That's 10 gigabit per second, one Type A and one Type C. Then, of course, our Intel NIC and our audio solution, which is based on a Realtek ALC 1220. The Realtek ALC 1220 is a 7.1 channel high definition audio codec, and it does support optical SPDIF output. This is MSI's Realtek ALC 1220 implementation, Audio Boost 4. That is, of course, you know, based on the Realtek ALC 1220, so you get all the characteristics of the Realtek ALC 1220 with your audio solution. It is, of course, on an isolated part of the PCB, which helps cut down on noise and crosstalk and other digital interference that you get from, you know, high-speed digital peripherals, so that helps. Then, of course, we've got our massive TR4 CPU socket. This is pretty much the same CPU socket that, you know, AMD's EPYC CPU uses in the server market. Of course, it's keyed a little differently, so it's not exactly the same, but it is a huge number of pins. CPU installation also requires the use of a torque wrench so that you don't, you know, sort of over tighten it. So it's a little bit different than the lever based installation. So there's a protective cartridge and a protective cover. You know, it's a pin grid array, which is the first time that AMD has been doing this. If you've looked at other builds and you've seen, you know, Intel CPUs for a while now have used this land grid array thing where the pins are actually on the motherboard rather than the CPU, but this is a first for AMD on the desktop. The Opteron server CPUs, of course, use also the LGA sort of mechanism for interfacing with the CPU, so that works pretty well. The other exciting thing about this CPU is that it's the size of a Pentium Pro. The Pentium Pro was like a super exciting CPU in like 1996 or 1997. I mean, sort of, kind of, not really. I mean, if you were really into things, and you know, you can be a DEC Alpha snob or something like that. But my goodness, Pentium Pro, and so this CPU is exciting just because it's kind of like a modern Pentium Pro in that it's actually really good and really exciting, and you know, new technology and innovation and that sort of thing. So for all of our testing, we use this lovely Lee test bench PC setup. I'm just going to mount this in here. We're also using a Corsair H115i, which is, you know, based on the Asetek sort of rough design, but it's of course been tweaked for Corsair. And the Threadripper CPUs come with an Asetek adapter because this CPU mounting system is huge and different than everything else on the market. So it was really awesome of AMD to sort of anticipate that people are going to have trouble mounting their CPUs, and they include an adapter bracket for really popular closed loop coolers. Now more coolers are coming. I've got some Noctua coolers that are on the way that are going to cover the CPU fully and completely. Those are air coolers, so it is possible to cool Threadripper with, you know, your tower style coolers as opposed to an all-in-one. But you know, it remains to be seen if that's going to limit your overclockability or heat production or any of that. But we're going to get this set up on the test bench and put it through its paces. Now the IOMMU situation on this board is decent, but kind of interesting. It's not perfect. Some of the PCI Express slots are grouped with the M.2 slots, and I'm not really sure why. So I installed 3 graphics cards and an Intel Optane M.2, which just shows up as a regular, you know, NVMe type device, and you can use it. I mean, it's only 16 or 32 gigabytes, but you can totally use it. The read speeds and the write speeds aren't that great, but it works. It's fine. It's good for testing. So it put one of the VGA cards and the NVMe in the same IOMMU group. The onboard peripherals like the Ethernet and SATA, those tend to be grouped together. There's a couple of different groups that have several devices grouped together, but otherwise it looks pretty good. I think if you carefully chose where you physically place your M.2s and your PCI Express peripherals, you wouldn't run into too much trouble unless you had a fully populated system. And that's too bad, because this would be the perfect platform to build, you know, 7 gamers, 1 PC, or 9 gamers, 1 PC, or 47 gamers, 1 PC, or whatever, it happens to be, just as long as we can get everything into separate IOMMU groups. Hopefully that's something we'll see with a future firmware update that's a fix, just like we did on Ryzen. Be sure to stay tuned on our Linux channel because we're going to do a full video on the whole IOMMU rundown on Threadripper if you haven't already seen that. If you're not already subscribed, you should totally go subscribe to our Linux channel. That's been a really quick look at the MSI Gaming Pro Carbon AC on the X399 Threadripper platform. This thing is beastly. Don't let gaming in the title fool you. It's all business. This is a really exciting platform from AMD, and this is a really exciting board from MSI. We're also going to do a full tour of the UEFI right after the credits bump, so if you want to see all the screens of the UEFI and all the options, well, there you go. You got it. I'm Wendell. I'm signing out, and I'll see you later.